Sharmila, Shrutika, connection done beta. Fine. So now look here. That time it was like buffering a lot, so only I just gave a rest and then again started. Fine. So now look here. So the most important thing is we are understanding about work and energy. In that we have learned one very important thing, that ki energy is the capacity to do work. So when you will have energy, you will be able to perform any work or activity. Okay. So in simple word, I just explained this one. Now another important point is, last class I talked about exactly hammering, and hammering one example is there. Another example for uses of energy is cutting a piece of wood. The log of wood, when you are cutting it, that time also the log of wood, when you are cutting it on the axe, you are applying a shot of energy. Means a shot of energy means an amount of energy you are applying on the axe. So you are doing an activity. In that activity, what you are doing is you are taking a piece of axe on the back portion of your head, and then with a very high force you are exactly what you call hitting one part of the log of wood. So when the sharpness of the axe will be allowing the wood to have cut into two pieces. So that means what? In this activity, where is force, where is energy, where is work? Now you have to tell me, in this activity, where is force, where is energy, and where is work? Where is force, where is energy, and where is work? So you have to decide and you have to tell me. I told you an activity, in that when you are cutting a log of wood, in that you have just used axe, and with that you have exactly hit the wood with the axe, and there, where is the energy, where is the work, and where is the force? Now think nicely and tell me the answer. Think nicely and tell me the answer. Give me the answer after thinking about it. Give me the answer after thinking about it. Where is the energy, where is the force, where is the work actually? Where is the work actually? Now think about and say the answer. Let's see who is going to give the answer first. Shrutika, Ashwin, Avinash, everyone start answering the question. Start answering the question quickly. Now there is no problem. I just asked a simple question. I just asked a simple question from you. Ki when you are exactly going to hammer, where you are exactly going to use the energy? I am unable to present in the Google Meet, so only I told live stream. I am repeating the question, Ashwin. I am asking that a log of wood will be there, and on that you are hitting with an axe. So when you are hitting a log of wood with an axe, so what you are exactly doing? What you are doing? You are exactly applying force. Energy will be there, work will be there. Where and all work, energy and force is there? Where and all work, energy and force is there? And how we can represent it? Work, energy and force. These three things are there. Where and all they are present. So you have to exactly think and explain nicely. Quickly explain. Hi Ekta. Quickly explain. Explain fast. Let's see. You'll be able to explain or not. Just tell. Just tell the point. Force will be created when it hits the log. Okay, Vishal. When it is hitting the log, that time force is created. Okay. Where is the energy? When you utilize the energy, means first thing is that there will be different locations. If I am going to hit like this, if I am going to take my axe at back and then I am going to hit, which one more force will be there? Which one more implementation of or usage of energy will be there? This one more energy usage, or from back if I am taking my hand and from there if I am hitting, where energy will be more used? Where energy will be more used, and whatever energy I have used, where will be the force more? So energy will be there in its body. Thank you, beta. Thank you. God bless you. second attempt to energy will be more. Yes, a simple concept is there. You have to understand that when you do an activity, the amount of energy you are using determines the type of work. Okay, so this is what I am talking about, and that is very, very important. Okay, so that means what? When you do a work, how much energy you are using, that will determine the type of work. So if I want to cut vegetable, I cannot keep my knife at back and I cannot hit it, because it will be maximum force. It will be maximum force. The one where I am applying more energy will be, means it is just converted into force, and there the force will be more. So work done will be more. So where I am not using that much work, if I can use that, means it is not going to work. Fine. So you have to understand that though energy and work, they both are exactly dependent, they both are helpful, means energy possessed in the body will allow you to do a work, but different type of work uses different amount of energy. And in different type of work, when you are using different amount of energy, different type of force will be implemented. Different type of force will be implemented. Till here everybody understood this point or not? So for different activities, you will be using different energy, and that energy usage will determine the type of work, and that particular work will be taking a particular amount of force. Okay, so that means while taking it back, absolutely. So first, how much energy is present inside your body, with that energy you will apply. So you will convert the energy into force, and what energy will get converted into force, that force will be the external force. Means the moment you will hit the log of wood, now the wood is exactly going to show reaction, because now it has just experienced an external force. The moment it has experienced an external force, it will be breaking. It will be breaking. So work will be done. It will be breaking and work will be done. I hope you might have understood this point. So I hope you have understood this point. Come on, quickly tell me, did you understood this point? Where is force, where is energy, and where is work done? Come on, quickly say. Now will you be able to give me one example where you can say that work, energy and force, three are there? Just give me one example. Just type an example where work, energy, force, all three will be there. Work, energy, force, all three will be there. Understood, Darshini? Work, energy, force, all three will be there. So just answer. Vishal, I really want a very smart answer. Where is energy? Energy is inside you. That energy will be converted into force, Shrutika, because I am going to hit a log of wood with an axe. For that, I first restored the energy, and then I converted that energy in the force. The sharp edge of the axe will be utilizing that force in the form of energy to hit the log of wood, to convert it into two pieces. To hit the log of wood, to convert it into two pieces. Just tell me fast, you have understood or not? Yes, cutting. So Aishwarya has given an example, hitting a ball in the wall. So absolutely I am going to take example of Aishwarya, that what she has told me, that auntie, you take a ball, I kept the ball. Now I want to hit the ball on the wall. So what I am going to do, whatever energy is present inside my body, with that energy I threw the ball. So that means the energy converted, the energy from my body got converted into force. That force is experienced by the ball. Now I am not experienced the force. I have given the energy to the ball. The ball took that energy as a force, and with that force the ball is having acceleration. With that force, the ball is having acceleration. Are you understanding? Work done is force into displacement. Work done is force into displacement. Understand this point very nicely. Work done is force into displacement. Work done is what? force into displacement. Force is nothing but mass into acceleration. The moment you have used the energy of your body and you applied a force on the ball, now the ball according to its mass will have an acceleration. Now according to its mass, it will have an acceleration. Now when it will have acceleration, it will have displacement also. It will have displacement also. Now the ball is going to hit the wall. The moment the ball is going to hit the wall, work is done, because force and displacement both are there in that activity. Force and displacement both are there in that activity. Come on, quickly tell me, force and displacement both are there in the activity. You understood this point? So karate ma'am is breaking with a hand in a nice bar. Yes, you can use that. You can use that example. You can use that example also. Now come on, tell me, you understood this one? Understood this point or not? So where is work, energy and force? So first thing is that energy converted into force. Force will be exactly, when force will be there, that force will have displacement and work will be done. The force will have displacement and work will be done. As simple as it is. So you have to keep on generating connectivity. So this connectivity is there. So I hope you might have now understood, na beta? Now understood. So that's why I told you to give example rather than I am using my example. So when axe I have taken, so my body usage, what is the usage of the energy present in my body? I restored and applied force, and the force which I have given to the axe hit the log of wood, and it has done work of separating the wood and breaking it into pieces. I hope you have understood this one. So work and energy are related to each other. That is, energy is the ability to do work. So energy is the ability to do work. Ball taken, converting the energy into external force. Force allowed the ball to have acceleration according to its mass, and then it will have displacement. It will have displacement. Oh, your baby sister is asking that I have not wear my specs. Seriously, now only I am remembering that I am not having specs right now. While playing badminton also very good. Hitting cork with racket, absolutely. Thank you so much. These are the examples what we can take. I seriously am missing my specs. Where is that? So in hurry burry I lost it somewhere and I forgot to wear it. Fine. Okay. Just thank you for reminding me. I really lost it somewhere. Fine. I hope you might have understood this one. So where is work, where is force, where is energy? I think now another important point is, if somebody will be asking you energy is a scalar quantity or a vector quantity, then what answer you are going to give? So if somebody will be asking you energy is a scalar quantity or vector quantity, then what answer you are going to give? Energy is a scalar quantity or vector quantity. What answer you are going to give? Scalar or vector? Scalar or vector? Scalar. Yes, energy is exactly a scalar quantity. Now, I am asking from you, why energy is scalar quantity? If you are saying that energy is a scalar quantity, then you have to answer my question that why energy is a scalar quantity? Why not vector quantity? Why energy is a scalar quantity? Why not vector quantity? Just answer my question. Energy is a scalar quantity. Why not it is a vector quantity? Think and say the answer. Scalar, why not vector? Yes, everybody is telling that it is a scalar quantity, but you have to answer me that why it is exactly a scalar, not a vector. Okay, it has no direction. Absolutely correct, Ashwin. So it is only having, Shrutika, it is only having magnitude, but it is not having any direction. Since energy magnitude is there but no direction is there, that's why it will be considered as scalar quantity. It will be considered as scalar quantity, though it is very, very important for doing doing work, but then too it will be considered as scalar quantity because it is having only magnitude but no direction. Only magnitude but no direction. So now what is the unit of work and energy? The unit of work and energy are same. This PDF will be available to you. So this is because energy doesn't need direction, only magnitude. Very good, Ekta. Now another important point is, if somebody will be asking you this question that what is the unit of energy, then you have to say that SI unit of work is joule. In the same way, energy SI unit is joule. So work and energy has same SI unit and that is joule. Work and energy has same SI unit and that is joule. I hope you might have understood this point also. Work and energy have same SI unit and that is exactly joule. Work and energy is having, yes, very good. Work and energy has same SI unit and that is exactly joule. I hope you might have understood this point. Shall we go for the next one, please? Fine. So now we are going to say that bigger unit of energy. What is the bigger unit of energy? The bigger unit of energy is kilojoule. Okay. So 1 kilojoule is equal to 1000 joule. So the bigger unit of energy is joule. So 1 kilojoule equal to 1000 joule. 1 kilojoule is equal to 1 kilojoule. In shortcut you can write 1 kilojoule. 1 kilojoule equal to 1 kilojoule equal to 10 to the power 3 joules. Okay. And 1 megajoule. 1 megajoule is higher than kilojoule. Okay. So if somebody will be asking you, 1 megajoule will be equal to 10 to the power 6 joule. Okay. Or 1 megajoule will be equal to 10 to the power 3 kilojoule. So write this unit, they are very, very important. So now look here, I just explained that 1 kilojoule is 10 to the power 3 joule, 1 megajoule is 10 to the power 6 joule, or even you can say that 10 to the power 3 kilojoule, or even you can say that 10 to the power 3 kilojoule. I hope I have made this point clear to you. So what is the SI unit of work and energy? The SI unit of work and energy is joule, that is same. Now 1 kilojoule. Kilojoule is a bigger unit of energy, so it is 1 kilojoule is 10 to the power 3 joule, or 1 megajoule is 10 to the power 6 joule. 1 megajoule is how much, beta? 1 megajoule is 10 to the power 6 joule, or 1 megajoule will be equal to 10 to the power 3 kilojoule. 10 to the power 3 kilojoule. I hope you might have understood. So last point, just remember, 1 megajoule can also be written as 10 to the power 3 kilojoule. 1 megajoule will be written as 10 to the power 3 kilojoule. So now we are going to go for the next one. How many types of energies are there? How many types of energies are there? So now look here. One simple thing is that in last class I was talking about, I was not well that time. Now also my health is not so good condition. But energy, can you teach the unit in CGS system, auntie? So CGS system, okay. But right now, shall we go CGS system? Who is teaching right now? Convert it. See, joule is what? Newton meter per second. Joule is what? Newton meter per second. Joule is what? 1 joule. You know that work is equal to force into displacement. Okay, work is force into displacement. So 1 joule will be 1 Newton into 1 meter. Okay, 1 Newton into 1 meter. Now convert Newton, 1 Newton. Now 1 Newton will be what? Mass into acceleration. Okay, 1 Newton, you know that force is mass into acceleration. No other work left than this work only. So now look here, mass into acceleration. Mass is exactly coming in gram. Mass is coming in gram. So now force is 1 Newton. So 1 Newton is 1 meter. So 1 Newton when you will be taking, then it is exactly going to come as, because mass into acceleration will be there. So mass is taken as kg. Acceleration is meter per second square. And here meter is there. So 1 kg meter square per second square is equal to 1 joule. Now convert kg into gram. 1000 gram. Meter into centimeter. Now it got converted into CGS. Gram, centimeter and second. It got converted into gram, centimeter and second. It got converted into gram, centimeter and per second. It's just a simple activity. See, you have to take Newton. You know that force is mass into acceleration. So force is mass into acceleration. Now mass is coming as 1000 kg. Sorry, mass is coming as 1 kg. If I am going to take everything unit I am taking, then acceleration is 1 meter per second square. Acceleration unit is meter per second square. So now, and here displacement SI unit is also m. So now if you will do this, Shruti, here it is going to come as 1 kg meter square per second square. So 1 kg will get converted into 1000 gram. So convert it into 1000 gram, meter into centimeter. So 100 into 100 centimeter, square centimeter, and second will be same. So that is CGS system. Yes, and then you can call it as dyne. So I converted it, CGS system. Now you can call it as dyne. I converted it into the pure conversion system I have used. I just converted your meter second, what you call MKS into CGS. I converted MKS into CGS. 1 km MKS, you call it by dyne or something, whatever you are, when you are going to call it in dyne, then you have to understand that here this system is MKS system and this system is CGS system. In CGS system, that is, this 1 joule will be 1, 2, 3, 4, 5, 6, 7, 10 to the power 7 dyne. 10 to the power 7 dyne. I converted it. You want name. I have given value. You have to understand this. You want name. Name is just dyne, but the thing here is I converted it into value. So next time if somebody will be asking you, you can say that 1 joule is equal to 10 to the power 7 dyne. So you can go one step advance and say them. You can go one step advance and you can say them that I know how to convert joule into dyne, the another SI unit. I thought you were asking the value. Okay, so that's why I have given you the value, asking the value. I thought ma'am is teaching you to conversion system teaching you. Krisha, it's a very simple system. In between the classes, I had numericals today to discuss, but I'm stopping myself. Exactly, you have work done will be 1 joule. So you know that work done is equal to force into displacement. So 1 Newton force into 1 meter. So you know that 1 joule is 1 Newton into 1 meter. So now 1 Newton is, Newton means what? You know that force is equal to mass into acceleration. Okay, force is nothing but mass into acceleration. So when force is there, mass into acceleration, mass can be taken as kg. Acceleration unit will become meter per second square. And here meter is there. So I just converted it into CGS system. CGS system, it will become 1000 gram. This one will become 100 centimeter. And this part will become 100 centimeter because 1 meter is 100 centimeter. Okay, and then by second square. So it is going to be 10 to the power 1, 2, 3, 4, 5, 6, 7 gram centimeter per second square. That is 10 to the power 7 dyne. So 1 joule is equal to 10 to the power 7 dyne. I hope now you might have understood. Understood or not? Understood now? Yes. Ashwin understood na beta how to do conversion? Understood? Krisha, so beta when they will be asking, I thought you were asking the value. So only I got like, why you are asking the value suddenly? You are only wanting the name. Then you could have said, na, kya auntie, in CGS system what it is called. Then I'll say that it is dyne. But okay, anyways, it is good na, you learned this. Isn't it good, Shruti? You learned it. So if they will be asking, you will be able to convert it. So 1 joule is equal to 10 to the power 7 dyne. Huh? Isn't it good? Tell me fast. You learned the method, beta. Yes, na Shruti? No, beta, complete answer. At the time of doing numericals, more or less in higher classes, you will be needing it. So now only work over. So it's good only. Okay, it's good only. So now you know now how to do the conversion. So if they will be saying that you have to say in CGS system, you say that I will not say only the name, I will prove it also. I will not say only the name. Dyne energy he has written. Okay, now shall we go back to the class and learn different type of energies? So how many different type of energies is there? My kiddos are going to tell how many different type of energies are there. Come on, quickly say how many different type of energies are there. Kinetic energy is there, potential energy is there, heat or thermal energy will be there, light energy will be there, electrical energy will be there, sound energy will be there, solar energy will be there, nuclear energy will be there, chemical energy will be there. Many different type of energies are there. Okay, so 8 different type you can see here. Chemical energy is also there. So that means what? The time of doing chemical reaction, that energy released. So many different, so some are exactly here. Muscular energy is also there. Very good, Keshav. So muscular energy is also there. Thermal energy is there. Light energy is there. Electrical energy is there. Sound energy is there. Solar energy is there. Magnetic energy, magnetic energy. Energy possessed by the magnet is magnetic energy. Okay, chalo, let's take that point also. Nuclear energy. So some 8 I have just showed you that these are the different type of energies. Some 8 I have showed you that these are the different type of energies. So now we are going to talk about this energy in much details. Fine, so we are going to talk about this energy, but first we are going to start with wind energy is there. Very good. Chemical energy is there, wind energy is there. Yes, different type of energy will be there. Different type of energy will be there. One of them will be exactly going to be kinetic energy and potential energy. So first what we are going to do is we will start with kinetic energy. Okay, so kinetic energy is defined as energy which is possessed by a body due to its motion. Okay, when the body will be having energy due to its motion. So like I am standing here right now, which type of energy I am using? Kinetic energy or potential energy? Right now I am just standing in one place. I am just standing in one place. Now since I am standing in one place, do I have a kinetic energy or potential energy? Come on quickly, let's see. My children are so smart, they can answer me so fast. Now tell me quickly, is it going to be kinetic potential energy or a kinetic energy? Which type of? Hey, super. I was knowing who will give the answer first. So Vishal has given, Keshav has given, Ekta has given. Yes beta, because I am standing, so it is due to my position, not by motion. But if I will be running, or if I will be jogging, or if I will be doing some activity where I am showing motion, that time I will have kinetic energy or potential energy. That time I will have what type of energy? That time I will have what type of energy? That time I will have what type of energy? Very good. That time I will be having kinetic energy. So that means we understood one very important point is kinetic energy of a body is due to its motion, not due to its position. So kinetic energy of a body is due to its motion, not due to its position. So now one example is coming in my brain, but that is a khatarnak example. So I am not going to give you that deadly example. Okay. So you have to give me some examples of kinetic energy. Then if I will feel, then I will give you that. So now just give me some examples of kinetic energy first. Give me some examples of kinetic energy first. Let's see, my children are how much smart to give some examples of kinetic energy. So they are telling that all moving objects possess kinetic energy, that we all are knowing. All moving objects are exactly having kinetic energy. But one khatarnak example came in my brain. So you know that walking, running, but okay fine, walking, running is there, ma'am. We will obey the discipline, ma'am. Okay fine. Jumping, yes, jumping is exactly a boy running when a dog chases him. Ashwin, you are seriously, like, I was thinking about that only. Like when some animal will be kicking someone, Ekta. But seriously, Ashwin, you read my mind. Exactly, I am having the biggest fear. That means the animals who are chasing you now, they give you a very nice amount of motion. Means you will have a very nice running experience there. So two times I think in my life dog chased me. I was running, dog was behind me, and luckily the dog I won the race. Otherwise I could have been in hospital taking injections. So that is what suddenly whenever I am teaching kinetic energy, falling from high, fine, then adrenaline push. What is that? Fine. So different type of activities are there. Kicking someone is also one of activity. Dancing is also utilization of kinetic energy. Fine, I can take that. Dancing is also one type of kinetic energy. Dancing is also one type of kinetic energy usage. Okay, fine. It's good examples. We will run faster in our life. That is a diplomatic answer. That is a diplomatic answer, because when we are talking about running in life, that means practically you are not running. Practically you are not running. In brain, whatever activity you are doing, that is exactly like you will say that, hey, that person did this much progress, that person was always running in life. So that they are exactly diplomatically, or it has like psychologically we are reflecting about the person activity, but we are not talking about physical activity. Okay, so that time we cannot be able to what you call support the answer by some values. So that time we can say that is exactly an activity. Beating someone with a force is really a very super activity, huh? So all moving object possess kinetic energy. All the moving object is exactly they will move. Yes. So all the moving object is possessing what type of energy? All moving object is possessing kinetic energy. Super fantabulous answers. So yes. So all moving object, they will be exactly using kinetic energy. So now next important thing is, now let's see some examples of kinetic energy. A moving hammer, as it drives a nail into a wall against the resistance offered to by the wall due to its kinetic energy. Yes, another important point to be noted, sir and madam, that if I am having a nail, I am having a hammer, and I want that nail to go inside the wall so that I can hang something. For that, what I am doing here is I am applying force. So what type of force? External force. Where I am applying? With the help of the hammer, I am going to apply the force on the nail. So at the tip of at the what you call head of the nail, if I am going to apply force, then against the wish of the wall, exactly the force will allow the nail to go inside the wall. Okay, the force will allow the nail to go inside the wall. So there is also something. So moving hammer, as it drives a nail into the wall against the resistance. That is a very important point. A moving bullet can penetrate even a steel plate due to kinetic energy, which it has on account of its high speed. Yes, the another example is, if we are going to talk about bullet. So definitely bullet is having a penetrating power. It can pierce inside the plate. A plate is something, it can go inside the wood also. So that is also one of the example. Okay, the kinetic energy. Now another is flowing water. The water which is exactly flowing in river, it is having, if it will fall from a height, it will have the capability to rotate the turbine or the wheels, and it will be capable of driving energy. It is capable of using that energy. It is capable of using that what better? It is capable of using that energy. So that is also a type of kinetic energy. So we are harnessing the motion of the river water. That is, we are utilizing the stream of the the river current we are utilizing. So that is also capable of giving energy. Okay, ma'am, we will faster in our life for first time when a dog chasing us. 100% beta, when a dog will be chasing you, that time you will feel like you are the person who can win any type of Olympic game, specifically connected to running. A ball rolling on a surface because it can set another ball into motion, striking it. So 100% yes, running is one shot. Another example part is if we are going to take a ball and we are talking about the ball movement on the floor, that time also we can implement and we can say that yes, the motion of the ball can hit another ball. See, two balls are there, you apply force on one ball, the ball will roll, and after some time another ball is kept, so it will hit the another ball, and then both will come in motion. So 100%, that is what there is exactly implementation of force by using energy, and after that it will do work and the another ball will come also in motion. So that is kinetic energy will be exactly provided to the second ball with the help of the first ball. A falling body, as it can break something on which it falls. 100% it will break break itself also on what object it is falling, that also will be broken. So moving wind can do work in turning the blades of the windmill, correct only. So that means if we can see that wind can also have, that is the wind energy. I think Keshav or Vishal, any one of you has given the example of that. So when wind will be there, so 100% the movement of the wind can rotate the blades of the wheel, and that is what the rotation of that, it is connected to shaft, and shaft is connected to turbine, and then the energy will be stored in the form of electric current. Energy will be stored in the form of electric current. So all these things are there. So now till here we have done our work. Next class we are exactly going to do another activity. Next class we are going to find expression for kinetic energy. Okay, next class we are going to find expression for kinetic energy. Now it's time, because of network issue, it got delayed. So now it's time to start maths. Fine, it's time to start maths. So I'm just no break. No break means 2 minutes break. Now I'm going to connect directly to maths class. I'm going to connect directly to maths class. Just 2 minutes I need, and I want all the students with me right now. Probability section we are going to do, and with probability, what reply Keshav you want? Keshav is asking something. Energy will be possessed only when it is displaced. No, the thing here is work will be done when only it will have displacement. See, you do lots of activity, Vishal. You do lots of activity, but all the activity will not be considered as work done according to physics. They are work, but they all will not be considered as work until and unless you don't have displacement. Until and unless, Rahul, don't say me bye. We are going to connect again. We are going to connect again in 2 minutes. Fine. In 2 minutes, no break, because already that internet problem has created lots of time gap. I'm having another back to back. After your class, I'm having biology class. So I have to start now only.